You're in Jasmine, and this session is The Future of Securing Intelligent Electronic Devices Using the IEC 62351-7 Standard for Monitoring by Andrea Carcano, Alessandro De Pinto, and Yannis Dragoni. Please remember to silence your phones. And now please welcome Andrea Carcano, Alessandro De Pinto, and Yannis Dragoni.
Thank you. Thank you so much. Good morning, everyone. So today we're going to have a 25-minute session, and the goal of this session is to talk to you about a standard, but we would like to talk to you about that standard in a way that is very technical, as I would like to do stuff with some real example, with some real demo. So now, before getting the presentation, let me do a quick introduction about me and my colleagues. So I'm Andrea Carcano. I'm the founder of Nozomi Networks, a company focused on industrial control system cybersecurity. I did a PhD focused on SCADA security, at the beginning on the offensive side, and then I moved on the defensive side. And then I worked for almost 4 years in a security operations center for an oil and gas company. And after that, I found Nozomi Networks.
Hello, everyone. I'm Alessandro Di Pinto. I lead the security research team in Nozomi Networks. My background is focused on penetration testing and reverse engineering.
Hi, everyone. My name is Yannis Dragoni. I'm also a co-author of the Triton research presented last year here at Black Hat. I'm mainly focused on offensive security and vulnerability research, and I'm also a member of the Global Shaper community.
Yeah, thank you. Thank you, guys. So let's go now to talking about the presentation that we're going to discuss today with you. So a quick agenda about the presentation. We would like to just talk very quickly about the state of the art about the smart grid. Give you a little bit of knowledge about the standard, IEC 62351, and then show some real demo example about an infrastructure that we build in our laboratory on some attacks and how that standard can help with the right tools to identify some sophisticated attacks against an industrial control system. So, good. First of all, let me talk about smart grid. And I want to start with a very basic question. How many of you is familiar about what is a smart grid? Let's say 50% in the room. So very quick, just to set a bit of context, what is a smart grid? So let me start with a grid, and then I will tell you what is a smart grid. So a grid is everything that is taking in consideration electric generation, transmission, distribution, from the producer to the end user, related to energy and electricity. So what is really interesting, a concept that is really interesting today is the concept of smart grid. So basically the concept of smart grid is a grid, but with the possibility for the end user to be an active part in the network. So an end user can produce electricity or can consume electricity. That is something that it's crucial for our future. We have many cities all over the world that are running experiments related to smart grid, and it's a hot topic because it can improve a lot the efficiency, but also from the cybersecurity perspective, open up a lot of discussion from hacking and defense perspective. So why there are some challenges on smart grid? Mainly for 3 reasons. One is technical challenges. So technology that are there today in the grid were developed many years ago. Systems are insecure by design. We don't have protocol, designed for this type of context. Also, we have people are always a challenge, as you know, right? We are always a challenge on the cybersecurity perspective because of training, because of lack of knowledge. So especially now that we are introducing that concept, it will be very important to invest in people. And then, of course, OT solution requirements in general. So before the 62351, there was not a standard dedicated to that, and we will see in a second what this standard is doing. So that was a lack until today that we have in this contest. Now, let me go a little bit more in deep talking about the standard. And again, very quick, because I want to give enough time for show you some demo and some real interesting stuff. So related to the standard, what is this standard? And in particular, I will be focused on the part 7. So first of all, we are part of the Working Group 15. Working Group 15 is an international group working on the standard 62351, where there is multiple companies working on that standard. We have companies from the automation world, Siemens, Schneider, ABB, GE, Rockwell, and so on. We have companies from the network perspective, Cisco, Palo Alto, Juniper, and so on. And there is companies specialized in cybersecurity, like ourselves, Nozomi. So the goal of this entire working group is to try to design a new standard that take in consideration all the challenges that we have on the cybersecurity perspective for keep our smart grid secure. In particular, the standard is focused on, we're going to focus today on the part 7. The part 7 is the part relative to monitoring. So one of the things that we're trying to force in the standard is the encryption, the end-to-end encryption communication between the different peers inside a smart grid. But that's open up a lots of challenge around how we can really monitor my smart grid, how we can get real-time data if I want to monitor the communication of an entire grid that is not maybe related to just a city, but is related to an entire country. So that's our whole challenge that we have in order to monitor and get data from the smart grid perspective. So another things that I want to mention is that the part 7, the part 7 on this standard, as I mentioned, is focused on monitoring, and you will see in specific is focused on some protocols that we can find in smart grid. So here you have a few examples of the protocols. Today we're going to show some examples related to how this standard apply to SNMP. But it works very well also on the MP3 and other different standards. And to summarize, the concept is we always been scared about having active monitoring inside our network. I worked for 4 years in an oil and gas company, and I was the first one not allowing anyone to install an active technology inside the network, because technology inside our critical infrastructure are not designed for active polling. But what about if I will have a standard that is pushing and is by design having the technology ready to get someone asking directly them information? So, and that is the entire things related to this standard. So in this case, having an active approach with a PLC, an RTU designed from the beginning to receive query and question around which is your status, how are you doing, how many processes do you have running inside your system. So all these things can give us real-time information that can prevent attacks and give us a better visibility about what we're doing. So I want to stop here, and I want to pass the baton to my colleague Alessandro. And what we're going to do right now is we show you some demo that we build in our laboratory with a physical environment in order to demonstrate how that standard can be very efficient against some tailored attacks.
Okay, great. Let's see the active monitoring in action. In the next slides, we are going to show you 4 different scenarios targeting a real industrial process that actually we have inside our lab. We decided to recreate a fully working hydrodam process. On the right, you can see the process itself based on 2 tanks with water inside. Basically, the process is that the pressure of the air pushes the water from the upper tank through the lower one, and this creates electricity that basically it used to turn on 2 small lights that you can see in the video. The whole process is controlled using sensors and flow meters that actually control the level of the water. As soon as the lower tank is full, a pump is activated and it pushes back the water inside the upper tank. This allows the process to restart from the beginning. The sensors are connected directly with the gray device. which it is an RTU in charge for control all the system. Inside the black box, we have a classic HMI device used by engineers to control in real time the process. And finally, we have a Nozomi Guardian appliance using the smart polling in order to actively monitoring all the network. Okay, demo 1. In this demo, we are going to talk about physical attacks. But first of all, we need to define who is an attacker. In this case, the attacker can be or an external attacker, or even an internal one. So a person who is working inside the company. This is really dangerous because people inside the companies actually have access to restricted area. We'll show you a couple of examples about physical attacks. In the first one, the attacker is going to disconnect physically a sensor inside the hydrodam with the main goal to create disruption inside the process. Another example could be the same attacker going to target a core switch inside the network with the main purpose to disconnect the SCADA system from the process. Now let's see it in action. We will see the first example based on the sensor unplugged. At the top of the screen, you can see the data collected actively by our system. In this case, we are going to use the second last entry that basically is describing the health of the process. The status actually is set on OK because the process is working as expected. Right now, the attacker, that actually it's just me, is going to unplug physically the sensor. This attack is immediately detected by the system, and an alert is raised inside the Guardian. The key point here is that using the active monitoring approach, we are able to provide detailed information about which sensor inside the process has been disconnected. It is really useful to the engineers in order to reply immediately to the incident going to the specific sensor. Okay, in the demo 2, we are moving on a software-based attack where the attacker is basically going to upload a new ladder logic inside the RTU. A ladder logic is actually a code which instructs the RTU about what the process is. In this example, the attacker is not going to change the process, but it's just adding a new capability to the ladder logic in order to exfiltrate data from the process. But this addition is introducing an overhead on the CPU and the memory usage of this ladder logic. So now, let's suppose that the normal passive monitoring systems wasn't able to detect this attack. So the ladder logic is installed inside the RTU. We can still detect this malicious ladder using the active approach. We are going to use the active approach to monitor the internal status of the assets, in this case the RTU. This time we are considering the first two entries of the data collected that represents the CPU load and the memory usage of the process. We can see on the right the HMI displaying the normal process to the engineers. And in this normal process, we can see that the CPU load is below 2% and the memory usage is below 21%. In a couple of seconds, the attacker will start the upload of the new ladder logic, the malicious one, okay? Now it's uploading it. The system, after the upload, will immediately detect a spike in the CPU load and memory usage. And these two indicators are really useful to detect this kind of threat. After a couple of seconds, a new alert will be raised inside Nozomi Guardian, providing information about which was exactly the problem. In our example, we can see that engineers have been provided about information like the CPU load and the memory usage was too high for the device iLux RTU.
Okay, so let's move to the next scenario. Oh. So it's going to be another physical scenario, but first of all, how many here in the audience have ever heard about cyber squirrels? Okay, so cybersquirrel1.com is one of my favorite sites because it is a collection of all different attacks that our critical infrastructures receive all over the world from an interesting type of threats that are animals. It could be squirrel, rats, snakes. It could target our critical infrastructure for curiosity and create lots of damage. So in this case, let's suppose that we have our squirrel or any type of threat that is targeting our main power supply units that control the entire process and that could cause a blackout in our cities. So thankfully, the power supply smart grid are hopefully more complex because they're different type of redundancy. But this is just for passing the message that by using active monitoring approach, we can have a great knowledge, details on specific failures on specific units in our power supply system. And that is also related to the second scenario where we are going to target a redundancy system and mainly a backup unit related to our RTU. So let's see these scenarios in action. So for what concerns the redundancy system and the backup unit related to our RTU, the indicator in which we are going to focus is the last one, power supply. And as you can see, with just one single value, we can have the monitoring or the view of all the power supplies that are related to our system. So we have 2 for the RTU and 1 for the hydrogen process. So, and as you can see, as soon as our threat actor is unplugging the backup unit, we have an instant change in the relay indicator. Relay indicator that now it says that, hey, there's something wrong because your backup unit is off. And instantly, in our Guardian appliance, you will receive, the operator will see a precise alert that says, there's an issue in a specific slot of your power supply system. So you have to do troubleshooting, otherwise your redundancy is not working anymore, obviously. So for what concerns the process itself, as you can see, we have our process that is working properly. We have also an insider. I don't know if any one of you were able to see it in one of the tank. And the indicator in which we are going to focus is the hydrogen power supply that's right now is powered on, so everything is working fine. But as soon as our threat actor is unplugging the power supply, we will have an instant change that says that the hydrogen power supply is turned off. And we will receive in our Guardian appliance an instant alert that says to the operator, hey, there's something wrong because right now everything is stopped, everything is shut down. So you have to do something. For what concerns the last scenario, we are going to take in consideration what it could happen if we have a threat actor that is targeting one of the devices inside our SCADA network. Let's suppose, for example, the HMI. Okay? So we could have a threat actor that decide to target an HMI. The vector attacks could be several. You could have malware, you could have an exploit that leads the possibility to gain a full control of the device and as a consequence, being able also to pivot to the other device in the network so that the attacker will be able to have the entire control of the network and as a consequence, obviously, also in the process. But let's see this scenario in action. So in this case, we are going to focus our attention on all the tasks that are running inside the device. So as you can see, we can monitor all the processes, tasks that are running inside the HMI during the normal operation of our hydrojam. And in this way, we can create a sort of a whitelist. Okay, so a list of all the processes that I know that those processes are good to be running during the entire execution of my hydrojam, okay? In this way, we can detect as soon as we have a new spawn of new processes that is outside this whitelist so that we can raise an alert and say, hey, there's something strange that is working, okay? And as you can see here, we have our attacker that is gain access to the operating system of the HMI and is starting to execute a command and control. Okay, command and control for gathering intelligence, collect all the information related to the network, and being able to pivot his attack to other devices of interest. And as you can see, we have an instant alert of 2 new processes that are blacklisted because they are outside of the whitelist that I said before. So this is a process that in IT is quite a bit common. But normally you have to install an agent inside the device. I don't think that if you go to an operator, you will ask, hey, would you like to install an agent in your HMI or on your ICS device? I don't think they will be willing to do something like this. But in this way, by using active monitoring approach, we can have these details and being able to achieve the same result without having to install anything inside our device.
Thanks, Younes.
Yeah.
Thank you to everyone. So what we saw today in the presentation and what we would like you to remember and to, let me say, bring home about the presentation of today are mainly 3 things. So we show at the beginning a standard, a clear standard for smart grid protection that is forcing and is recommending also to the automation vendor to, by design, build equipment that provide health indicator about the status of all the components that we have in a smart grid or in a critical infrastructure. So we saw some demo about potential attack, and we saw how it's possible to detect that attack. You know, Alessandro showed some attack that was a physical attack. We show a potential attack to the logic inside the PLC, and the last one, we show a classical attack, basically attacking the HMI with a monitoring of the different process. So until today, was possible to identify this type of attack by a really invasive technology inside the OT networks. Passive or technology that are really disruptive or dangerous to be used inside our network. With the standard, and that is a second big takeaway point, with the standard from the future will be possible to, by design, monitor health status of our network, and with the right solution, this health status can be correlated in order to identify potential attack in a safe way. We're not saying, let me install a tool, a script that is pinging my PLC devices, and I don't know if my PLC devices will be still alive after I finish my active scan. No, no, no. The standard is forcing to have that by design and to expose some indicator. And the last things that we would like you to bring home after this presentation is that we already have some real application of that standard. The majority of the automation vendors are adopting that standard. So in the future, we will have that, we will see that possibility more often in the majority of the technology out there. So we are almost running out of time. We still have 1 minute, potentially for one question. Before eventually get a question, just a quick recommendation. You will receive a form for a feedback. So any feedback from you will be very appreciated about the presentation today. Thank you. Any question? Yes, there. There is maybe a microphone up there if you want, or if you want, I can repeat the question for you.
What's that website again that had all the attacks that you stated?
Cybersquirrel1.com.
It's a pretty interesting website. You can find lots of interesting type of curious attack to different critical infrastructure. So if you have any question or you would like to discuss a little bit more deeper, me, Younes, and Alessandro will be here after the presentation and in the speaker room. So thank you very much, everyone. Thank you.
Thank you.